We go. Okay. All right. So as I mentioned, I'll just introduce myself a bit more first, then we'll dive in. So my name's Patrick Pease. I am here at Borough Hackle, the building performance leader. So I lead our team of about 15 energy modelers, carbon analyzers, consultants, passive house experts, daylight, all of that. So we have a great team here. I have last count about 13 years of experience in the industry. Kind of started as a mechanical engineer, really focused on high performance design. My early career, I was obsessed with BIM. I did a lot of BIM. And then I kind of pivoted more into the building performance space. Part of that brought me to a startup where I actually developed my own piece of software called Load Modeling Tool. You sadly can't get Load Modeling Tool anymore. That's a story for several years later. And I also previously worked at Arup here in Boston. And I am involved on a couple of the ibpsa committees, which are fantastic. The certification one, and also the practitioner advocacy committee, which is great. I am also on ASHRAE standing standards practice committee. I think I got that right, 209, which is the building performance process standard, my favorite standard, and then also 90.1 the ECB, which is essentially the energy code. So I do a lot with those two committees as well. But what we're going to talk about today is game engines and kind of AEC, and why we at kind of Borough Hackle in this case is looking at them, but also why I think they're a great thing for us all to kind of think about. So really the reason we're looking at game engines is the three things we see here. We want a tool that helps us drive decisions. I think as modelers, as consultants, we're really good at producing data. A lot of our clients, architects, kind of building owners, have different response to a chart or a table of data than maybe we do. Maybe some of them really get it, maybe some of them don't. So it's a new way to really pull these clients into the experience of what is this data, how can we really talk to them a lot. And when we think about driving decision making, part of it's about reducing costs to get to that decision. You know, if it took us 10 meetings of going through these results again and again to get there, the idea is here, we put a little bit up front, we get a decision within that one workshop because they're like, wow, okay, we get it, let's move forward. So from that aspect, it's very beneficial. Also lets us look at understanding trade-offs. Kind of, let's not just look at energy. Can we visualize some energy, but also the daylight performance at the same time? Because maybe, you know, we've seen the gear with multiple windows is pretty energy efficient, but you kind of want some daylight at the same time. So you can see some of the trade-offs, cost, carbon you can mix into. And then answering questions in real time. This is an interesting aspect. It's not perfect within kind of what we set up, and I'll talk through it, but it does allow you to say, if you have a static image and you made a view of a building like this rendering, for example, if your client says, oh, what's happening over here to the left, you'd have to go back, make a new image, bring it back. But within the game engine, you just turn the camera and you're like, there it is. Let's look at it. And so that's really beneficial, really shortening that time between question and answer. So that's another reason we're looking at them. The way we think about it is really in three key steps. The first is to ideate. And here it's about collecting the questions that we're trying to answer. We're not trying to go straight into analysis. We're really trying to step back and say, okay, what are we trying to solve? So trying to define, you know, are we talking about the HVAC system? Is that, you know, the question? What's the basic HVAC system for this building? You know, we are doing a massing study. Is the massing what we're looking at? And then energy costs, is that important? Are we worried about the envelope and its impact for its costs or operational costs? So it's really making sure we understand the questions. And that enables us essentially to define or advise on, you know, these are the considerations we want to look at that to answer your question for you. So A option, massing, ABC, envelope XYZ, and intermix those things. But really making sure you start first with like sitting with the client and say, okay, what are the questions? So we can make sure we answer those correctly instead of going straight into some analysis. The the next step, kind of after that ideation, kind of defining the problem, is kind of going through, okay, how are you going to make your decision? We've defined what questions you have. What's the best HVAC system? Now the question is, what is best to you? So is it first cost that's really important to you? Is it operational cost? Is it body carbon? Or is it something else altogether? Something much less harder for us to simulate, but equally important to certainly some of our clients. Things like the availability of a component. Can you buy that, or is the lead time 12 months? The constructability, again, hard for us to quantify necessarily, but something that we can potentially build in if we get the right data and kind of give the scoring to it. And then other things like daylighting or space requirements are things that we could, in fact, build right in. And then once you kind of pull those together, kind of this idea of exploring. So once you have all of that, what your questions are, how you're measuring success against those questions, then essentially creating this space to explore the opportunities, to see how things line up, and really kind of presenting that with the client and walking them through what could happen there. So this is, I think, a first example of one of the more shoeboxy kind of game engines that we've produced, where we're kind of looking at the size of the shade and how's that look as far as like light penetration into the space beyond. So getting into a bit more detail with the game engine, I pulled some more of the process slides out so I could talk to them of like how it's all coming together. So the game engine is essentially an interactive 3D app. We are using technology Unreal Engine. There are others out there. I know Unity also has some capability for this. So I think there's some people using that as an engine. We just are an Unreal Engine. And really what we're doing is the engine gives us some things for free almost. It has this 3D modeling space. It already has controls in it to like move around and have a camera. That's like what this engine has. It has things like real-time rendering. Again, that's what the engine has. It's great. But what we're feeding into is essentially these physics-based simulations or things like CFD, and pulling that data in so that we layer that on top of what was already there, which is essentially a more static environment. So we're pulling that data in. And we can also do kind of add-ons such as a UI that gives us control over what we're viewing, or additional things like a table we can pull in, things like that. So there's kind of add-ons that we can have. The workflow to get out of these is not dissimilar to parametric modeling. In this case, this is a workflow that I worked on with a client about a year ago. And essentially it was kind of sitting down with them. They were working in Rhino. We're going to do the analysis through Rhino. So in this case, all the analysis is happening through a series of, Ladybug and Honeybee enabled analysis through Radiance and NG+. So not really new things. But we're layering on top of that is something that allows us to build a mesh. And that mesh is what we're importing into the 3D visualization. And I have another slide of kind of what that mesh is. But it essentially takes the visualization you would get within kind of the Rhino viewer, making that a mesh component, and then we load it into the Unreal Engine. So that's really just the extra step on top. But really what we have here is when we were talking with the client, they were going to pass us back and forth several Rhino models. So we wanted to have this idea of what's a feedback loop to say, okay, so that's a Rhino model. We agreed you were going to provide these layers that were going to fit with our scripts. First check, did it have the layers? No. Remind them they're supposed to have layers, feedback through. So we can work very iteratively together instead of constantly kind of fixing these models every time. So that was an important aspect of kind of utilizing that at scale and at speed. How we're doing a lot of the meshes, as I talked about, and bringing them into the engine is using what is called the BOM. So the BOM stands for Building Habitat Object Model. It is open source. It is generally created by the computation team here at ProHabble. I think they released it actually at sim-build world in Rome, if I remember, is when they released it. But it has essentially this toolkit to connect data from point A to point B. So there's a lot of these schemas out there. You wouldn't have to use this one. It's the one we're using, but it's essentially a schema to say, okay, I have mesh in one simulation software, Ladybug, IS, OpenStudio. I need to convert it into these components that our tool then transfers into the Unreal actors. And so this, I think, could definitely be done in multiple ways. And you can kind of see the amount of connectors that we've set up that allows us to do it. Mostly with Energy Plus, Radiance, and then ANSYS CFD are the main ones that we're using for day-to-day. I guess a bit more about the script is, in addition to the visuals, we always try to make sure we add a score in as well, because we want a way to essentially quantify, okay, the visual is beautiful, but when someone asks, okay, is that good? How do we say it's good or not? So we create that scale that's back in kind of that measure stays, first cost, what's good, first cost, what's bad, you define those. And so there's always kind of this metric layer as well, so that you could always take that more kind of step back approach and say, okay, it looks beautiful, looks like all the color is, red, if that's, good daylight in this case, but is that actually the best performing? Or is something else like really hurting here? And so we have various essentially schema to say, okay, define what those are. And in the various scripts that we've created, kind of pull that information through and then maps to essentially a template that we create within the Unreal Engine database, so we can kind of push it relatively quickly. But this idea of scoring, I think, is important because that provides, it takes that step back and provides that rigor of the analysis that we are doing. It's not just about the visual. It is about, okay, quantitatively, is this performing the way it should be? What's the number that we put to it? So that's an important aspect. I now have a couple case studies that I'll run through, and I'll go through just a couple, and I'll pull up a couple of visuals. But this is one of the first ones that the team did. It's actually for this kind of atrium space. This one's in the UK. And what they looked at is essentially optimizing the shading within this kind of skylight dome that worked with essentially the daylight, the glare, and also the solar heat gain, but then gave them a lot of kind of space to view. The visual was supposed to be to see as much of the sky as possible. So we kind of built this looking at glare with different types of glass, different components of shading elements or not. And I think this is a video. It let them not only see based on a time scale what's it actually look like, but also understand kind of within the space, okay, what does this mean if we're standing in this corner? You can see on the left here, some of these scores are really low. I think this is probably one of the bad examples, and then there's some better options that were looked at. It allowed them to see not only the impact of these options, so this G value, again, UK, so that'd be solar heating coefficient for us, but allowed us to see a lot of this, which is really fantastic. The really nice thing too about Unreal Engine, that environmental settings, that's essentially the sun location, that you can change any day, any time of the year, which is fantastic. And so you can layer that on top of the analysis, which is really nice just to see the sun. So that's one use case, kind of looking at, okay, how do you build these shades to get the pattern of light you want, and then also the performance of glare, etc. Another one that's really interesting, this one we saw a screenshot before. This one's also UK based, and here what we were looking at is overheating potential. So most apartment buildings in the UK don't have air conditioning, which 50 odd years ago was absolutely fine. It didn't get that hot. The world is sadly warming up. Oh yeah, absolutely. And And so one of the code requirements there is actually look at passive overheating. Like, will this place overheat? If it does, that's too much, sunlight going on. And so in this study, what they did is look not even at the full floor plate. As you can see, it's kind of a localized study just where the windows are. And looking through a series of options, in this case, they look at several parametric options to essentially analyze based on, balconies, window size, all of this. Could they prove out a design? I think in this case, they were looking for a series of multiple designs that would result in buildings that had daylight. So here we're visualizing daylight, but also that don't overheat, which is the critical requirement there. So it was, again, a very helpful one for, in this case, they were going to build, 100 odds of these apartments. And so selecting through, the window design was very important because if you build 100 of something, you want to make sure you like it. So this became very powerful for that. That's another kind of interesting example. So yeah, SIP is overheating. This is the overheating potential, and you can see somewhere in red. That means there's a lot of overheating happening. Somewhere in green, so they're pretty shaded. And that was the analysis for that one. This is now a slightly different study. This isn't energy or daylight. This is actually a CFD study. This is for an atrium space at a medical school here in Boston. And essentially they were enclosing what used to be an outdoor courtyard, putting a big glass roof on it. But then the question is, okay, is it going to, again, overheat? So we did quite a bit of CFD analysis looking at locations of diffusers. And in this case, what we're trying to visualize is not only the airflow pattern from the CFD, which gives us these kind of really cool dot pattern, but then also something we've been adding on, which is cool from the kind of the experimental part. I think it's going to get through this halfway through. Yeah. So these are streamlines of the actual airflow. And then here, kind of on the map, this is the actual temperature and operative temperature for those, grid points from the UTCI, or not the UTCI, from the CFD analysis.
Is that ANSYS?
ANSYS in this case, yes. And what we did is we actually enabled via the walk function, you could walk around and report out what's the actual field for that grid. So really, again, trying to take it out of traditionally just a printed PDF or something to really give them an experience of, oh, if you do this, this is what it's going to feel like in this location. Walk to this corner, it will feel like this. So it really makes it this much more, visual for the clients, and they can really experience it in some way.
Do you guys use this for data centers?
We don't do many data centers, actually. So no, I don't think we have. But I think you could, yeah. This is another example, and I might stick to one of the demos next, but this one I just like to show because we also are looking at it to do things like PV. So this is, I think it's an adaptive reuse project, and basically showing, well, if we did PV, what could it look like? But then also where's good PV versus bad PV. Really easy to color code here. We can see the self-shading yellow, not getting quite as much. So interesting. And then also looking at that idea of kind of that total scoring system. Again, just playing with visuals, like what's going to really kind of meet the needs of the story you're trying to tell, and then also the client that you're talking to. I think in this case, we were talking to the client was like a financial institution. So they have graphs like this for their internal like HR things and all of that. So it really made sense to them. Maybe it wouldn't make as much sense to say an architect on use of that type of graph, but kind of playing with the graphics as well. And then, oh yeah, the last one I want to show that we've been doing. I've actually been doing a lot of these projects, but unfortunately the projects I've been working on are confidential, so I can't show you. But this is one that was done, I think, in Singapore. And essentially, it's an outdoor thermal comfort study. So in this case, it's a log kind of outdoor, I want to say like giant balcony off some mega tower. And what the team did is, again, do that kind of outdoor thermal comfort, but then allow someone to like drop into the space and experience, okay, where in this giant park is it actually the most comfortable? Where is it not? Are trees helping? Are trees not helping? Things like that. What's the natural ventilation of it? Where's the air moving? Where's it not moving? And so this has been really beneficial as well, kind of at the outdoor scale, not just inside a building. Yeah, we're flying all over. This analysis is also, I think, really beneficial, kind of from a detailed aspect, and like places where aesthetics really matter, whether it's a park or something like that, because you can really kind of bring things in and say, okay, this is how it's going to look, this is how it's going to feel, and kind of speak to the client at that level. I think that's the last one. Okay, that's perfect. Actually, so this one, I'm going to pull this one up, and then I have one other I'll pull up as well. I'm happy to just kind of talk through everything. So let me pull this up. So what we're pulling up, this is the actual Unreal Engine. So they're like local executable files with essentially all the data baked in. I think that's one important thing about the implementation. We're not live simulating these things. Everything's pre-simulated except for the shading. The sun angles, that's live, that's dynamic. But all the simulation, that's essentially why we have that kind of ideate and measure steps. We basically want to design or decide on that design space, go out, pre-simulate it, and then have that really interactive kind of workshop where the client would be like, hey, here's everything. Let's go through it. And so this one is pretty cool. This is actually, it is the architectural school at Kennesaw State, just north of Atlanta. And this was a gallery space they had created. If I recall, unfortunately, it's facing south or west, I can't remember which. So it overheats drastically. And so we were kind of brought in to like do a lot of kind of on-site work, say, okay, what's happening? Look at the glass, our facade team was involved, all of that. And then we also, on top of that, it's like, okay, well, let's visualize this so we can really like see what the options are. And so I'll just fly into the space. And then under visibility settings, what I can do here, what we looked at is glare. And this one, we did a slightly different look at it. So here we have glare. And I should have looked up what this was. I think it's glare at different times of the day is what we did on this chart. This kind of like pie chart here. And essentially showing, for most of the day, lots of glare, really bad. Some parts of the day in the evening, okay. And then what we were looking at for this particular design was say, okay, what if we did blinds? And you can see a good part of it, a lot of the red's gone to yellow, but for a lot of it hasn't quite fixed it. So there were other things that we looked at to mitigate further. The other thing that was really challenging with this is kind of the operative temperature as well. You can see it's very hot by the window. Scale goes up to 95. There's pockets there, they're 95 inside. And so the team was looking at different versions of flow from different diffusers. So I think the standard that they had was just some square diffusers that's kind of intermixed near the roof. And they looked at different ones. So they did kind of half volume approach, which was slightly different. And then a slot approach to really kind of blow the air at the windows, just to see how that improved things. Oh, and then this one's cool. And then the other thing that's nice too, this is something that the team just built into them recently, is this idea of a section. So again, you can kind of cut the space, really look at different angles. There you can actually see the slot diffusers where the air is flowing through. And again, just trying to go through options with the client very effectively to say, okay, here's option A, here's option B. You know, obviously talking through what they're seeing, but giving them that kind of sense of understanding of this visual, say, okay, we understand how the air is flowing, how that's either beneficial or not beneficial.
It's like a 30 feet tall space and then putting a diffuser on top.
Yeah. Yeah. I can't remember what the actual solution was. I think in addition to the blinds, which there's actually, oh yeah, we rendered the blinds. I forgot about that. There they are. I think they ended up going with blinds plus, I think it was a slot diffusers, got them to like pretty close to the case they needed. But as you can see, like as built, it was hot.
Yeah.
People were sweating.
So is your CFD simulation there also responding to the way the blinds change the heating on the floor?
Yes. So for the CFD simulations, typically we run, our workflow typically has been we run an IES model first, and from that we get radiant temperatures for surfaces, which we plug into the ANSYS model.
How do you choose what time of day or what day of the year to use for that?
Oh, yeah. That's been an interesting challenge.
You run modeling IES first and then export the condition to CFD and then run
For the radiant?
Yeah.
Yeah,
We
we do. Yeah. But for time of day, because CFDs run over a minute or so. So for this one, I wish I'd asked the team. I'm assuming they picked likely a design day like in July, because it's very, very hot. For some of the outdoor thermal comfort items, though, however, we've been kind of erring more on a 95th percentile day. Because what we want to show is that interventions still have a benefit. And in a 95th percentile day, you know, you add in things like shading or fans, you can typically go from like, you know, very strong heat stress to moderate. And you're like, yes, I did something. On the worst case day from a design day or a weather file, you're going to go from extreme heat to like very strong. And so you still did something, it just doesn't look as good.
Sure.
And so we've been doing different things, whether it's like an indoor or outdoor.
I mean, like visualizations like this are a pet peeve of mine. Because like streamlines look very, like it makes it look like there is a specific airflow pattern that happens. But in a case like this, first of all, as the sun moves across the space and the area on the floor that's receiving that direct solar gain changes, that's going to change how air moves. And secondly, what you're showing is clearly a turbulent condition, which means that if you were to, turn this into a time step model and show different time steps across, you would see different airflow through the space, which I'm curious if there's a way to represent that.
The time space. The
ANSYS can run transient model. You run static first and then run transient.
Right.
But it just takes too much resources.
Right. It's definitely something we've been struggling with. Kind of the point in time visual like this is very helpful because you can pause and fly around. But no, it's a very good point that if you had the actual time space,
Would
in
it be
some ways it becomes a video.
right? Would it be even reasonable to like store that time space? Because you have to like store it in 3D, I guess. Like, so I mean, I know RWDH, like they make plenty of 2D animations that show you the like show you how turbulent flow changes over time.
Yeah.
But like here, it wouldn't be 2D, it'd be like 3D that you'd be storing.
Right. It is I wish my game engine expert can join us and maybe we'll get him here next time. But I do know that the Unreal Engine data schemers is helping us quite a bit on file size. So it is relatively efficient file size wise. So there's potential there, I think, thanks to what Unreal has already kind of built in for us. There's probably something we could do. Yeah.
What's your tool and what's your workflow? in a scenario like this?
Yeah, I mean, we don't have a way of representing like that time space either, aside from like we could do animations, but
But I mean, animation is based on a simulation linked to the animation, right? Where did that simulation happen?
right. So I mean, we have been moving a lot to open film.
Oh,
Uh,
okay.
Yeah, but before that, we were doing a lot of ANSYS.
Yeah, getting too expensive.
It's more expensive than Unreal, that's for sure.
At my previous job, we used the Cadence too, so they can link the external condition and the internal condition, run a static model, and then run a transient model. The file is like 100 gigabyte per run.
Yeah.
And then you probably need to use like a cloud run.
Yeah,
It's like one simulation costs you $2,000.
it does add up.
Yeah, so that would be, so it can do like what you described, like just at what cost?
Yeah,
Like,
right. Well, I mean, there's the cost of running the simulation, but then there's the size of the data that you're trying to bring in. I mean,
Yeah.
you're bringing the data in through Grasshopper, it looked like, or is there a separate process now to get this data in?
I need to double check. I believe we have a bomb component for ANSYS.
Okay.
that we didn't-
Yeah, all right. That seems more reasonable.
Yeah.
So we reached a point with Grasshopper where like the amount of data that we were trying to bring in slowed down too much. We couldn't do it anymore.
Yeah. Yeah.
have you guys used Star CCM?
I don't think so. What was that?
Star CCM, it's a Siemens CFD2.
We used to use it. That was before my time in Europe.
Okay,
Yeah. Not meaningful.
it does like it's really like transient like natively.
Okay.
So
Oh,
Interesting.
yeah, we've done mostly ANSYS, a bit of OpenFOAM these days. People keep dabbling with it.
are you guys sponsor us? Open phone?
Yeah, I mean, that'd be great. I
Okay.
mean, I don't know if Open Film's got any money, but if we could ANSYS, that'd be cool.
No, that's yes.
And it's just like they sell one more license and that's like half of our conference.
One license, 50 to 70.
I want to pull up another example, and then let's just open up for discussion on, this, and then also, we'll feature about chapter and stuff. But this is the first one I actually got to work on when I joined Bill Apple about 1.5 years ago. So this is for mixed use development in Arkansas. And this is actually the one that we worked closely with an architect on kind of the workflow of, they were playing around with massing quite a bit. We would get the render file or process it or plug it into this. We'd have it at the workshop and kind of went back and forth. So it was a really like dynamic kind of interaction, which was great. And I haven't opened it in 60 days. So, aha, there it goes. Look at that. And so what's interesting with what was interesting with this one is we were really trying to play with how do we visualize different parts of data. So things like sun hours, super visual, looks super great. We can visualize that. Irradiance as well. We can visualize that. Daylighting. In this one too, I got to turn the architect on. There you go. In this one, we were actually also trying to visualize things like energy and peak cooling load. These we struggled with. Essentially what we did is they said, okay, we can scale it for the cooling load. In this case, there were 5 different use types. So the different buildings have different colors based on what they are against each other. Didn't quite work.
What's the metric? Like cooling load, what's the metric? Like what the kBTU per?
This is kBTU per square foot, I think is what we have here.
Okay.
Yeah. Or like EUI. This didn't quite work. It didn't quite hit as well as some of the other visuals. So we haven't kind of gone further in this direction, kind of visualizing kind of that, well, the annual engine result. It is a single number. It doesn't quite look as interesting. But what we were able to see, especially on things like the glare and the daylight hours, we were able to optimize a lot through different massing. So we went through 5 different iterations of massing, A, B, which B and C are really similar. They're kind of playing around with things back here. And then we went kind of crazy, kind of changed it around. This one changed quite a bit. It's now an L, things like that. And then even down to E, which we kind of move things around altogether. But through the workflow, basically, they were able to feed us these different massings. We plugged it straight in, plugged it straight into the game engine. We met with them weekly just to go through all these things, which was, I think, really, really fantastic. It was really enjoyable too, just to be able to have these conversations quickly, because we talked about the workflow. We talked about how we were going to look at that during the meetings, things like that, which was really cool. And then the other thing that this project in particular that we spent a lot of time looking at was actually the sun hours. So this is, let me go back to A, because I don't remember what the comment was. So A, this was going to be an office area. This was going to be a hotel. And then this was essentially apartments. You would call them luxury apartments. I've lived in them like this. They're just apartments. But where we really looked at them with a lot was this idea of these quarters they created and kind of how livable and nice were these. And kind of what we discovered with them is kind of right here with the sun hours. Where's my scale is? I can't remember my scale. Sorry about that. But essentially, blue is very few. It's something like 500, and then red's the full like 2,000-ish that you would actually get. And so we basically had these conversations of how do we get more light into these spaces so that people would want to have a barbecue in the afternoon, want to like be in these kind of spaces. So that's when they kind of pivoted from just moving these blocks around, which really did nothing to what was happening here, into saying, okay, what if we, in this case, they tried to break things up height-wise so they get some more light in. We saw that didn't really make too much of a difference. And so they pivoted all the way here, which opened up these, same area with the built area, all of that. But now we have these very well sunlit courtyards that were just kind of much better amenity spaces. So it was really interesting that this is what we focused on, even though we were still running, EY, peak cooling loads, all of that every single time. Well, those changed really slightly. What we found was the really kind of, metric that was interesting here was this idea of sun hours. And it was a really cool way to visualize it with the architects. And so I think it's a really cool outcome and a really cool use case for the whole simulation and then the visualization of it as well. But yeah, I think I'll pause there, kind of sharing out game engine things, and happy to just chat more about it. Yeah, any questions to start?
Super cool stuff. I'll start, I guess.
Yeah.
To what degree do you need to like really understand how Unreal Engine works to be able to use something like this? Like, do you have somebody here who had that experience when he was hired, and he was able to leverage that, or is it something that he kind of learned on the job?
So we have the person that kind of built this out for us is actually on the West Coast in San Diego. And he's kind of a computational designer. I think he has some experience with some of these tools before. And then I need to get the full story from him, but he lives next door to the AEC salesperson for Epic Games that sells Unreal Engine. And I feel like they clearly got talking one day, and it's like, oh, it's not that hard, we'll build this out. But what they were able to build out is Unreal Engine lets you template things really easily. So we basically set up this template. So everything you see here, like these settings, that's a template. We don't build that every time. There's options as a template. Even this is an option, or it's a template. And so once that was built out, which I'm not sure how much effort that was, it's really plug and play in a way. It's like have the data, push it in. And so from that respect, it's been very repeatable, which is very cool.
Awesome. It's really cool that you can like visualize data like this to show it to people who don't appreciate a chart like we do.
Yes.
Which is confounding to me.
Yeah.
I was gonna ask about the process of building this out, but it was so someone from the West Coast was the one.
Yeah,
who created
so
this?
we do have, well, we purchased Unreal Engine, but it comes with support.
Mhm.
So they support us in kind of building it out. And now that we have this template, it's kind of plug and play for us, which is really, really fantastic.
So they were the ones who like built in like all the like the fluid mechanics into it.
No, I would say they kind of got us going with, how do you build, these kind of things into it? What's the data structures? And then we kind of went from there. Because it is, in some ways, it's probably as well documented or better documented than Revit, because there's so many video games and video game producers, and those put millions and millions of dollars in what they're building. So there's a lot that's already got into this engine, and so we're just using that really, which in a way I think is a great way to like bring these things that are really fun, but maybe not that productive, and something we can like use in our industry as well, which is great.
That's really great. Was there what made you realize that game engines would be something that you could use in this industry? I would not have thought about that.
I think it kind of started with, does ever remember, what was it, 6 years ago now, when like VR was like all the rage? I think I also tried out VR. I was like, okay, this is really cool. But then the aspects like with goggles and things like that was just so painful. And this is almost the in between of, it's still the idea of these powerful visuals, but like no one else put on goggles. They get seasick and all of that. And you can still have a lot of the impact of it without some of the pain. And yeah, you're still in it, just more in a friendly environment.
Are other trades in the AEC space using, like, do architects use anything like this, or do they have their own kind of custom tools to do fly-throughs to their spaces? Do you see, applicability elsewhere beyond this type of visualization?
Yeah, no, I could definitely see this being used by others. In the architectural space, they have their own rendering softwares that they're using. And I think maybe one of the challenges they might find with Unreal, what we can do, like very detailed visualization, is you can see like our context really pretty plain.
Yeah.
I actually don't know, getting textures on that might be a huge lift, and we're skipping that because it's not super important to us. That would be important to an architecture course. That might be a limiting factor of like how we see that aspect of it is. But I'm not as familiar. But the quality of the render, I think, is excellent. Also, as I mentioned, you can change your day and month dynamically, which is just really nice. And I wouldn't say, I haven't like done a simulation to back up and say, okay, is that exactly where that should have been? But again, for a tool like this, it's good enough. It's getting the point across. That's not the detail of the analysis. And so it definitely has some good benefits there.
Yeah.
So if I understood correctly, you said that the options are predefined. They give you all the options, you run the simulation beforehand and then do the visualization.
Yes. So I wouldn't say that necessarily. Often we will co-define the options with a client because they might not understand all the things they're looking at. So I guess in this case, the architect went through and said, okay, I have these four massing options. But we added on top, for example, it's like, well, let's look at some different window to wall ratios for you. So we think that's also going to be important. So we would potentially add additional options.
But it's not possible to change anything on the spot.
It's not, yeah, it's pre-print.
Yeah, so how feasible do you see that it's not something coming up, or like is it's gonna be helpful, or maybe computationally very expensive?
It could be. So, well, in this case, all the simulations you see are just run by a Grasshopper script I put together that triggers 5 different engine simulations and radiance on like a computer in the closet, and it runs all and then I import them. Could you speed up that workflow to pull this in quickly within like a matter of an hour? Yes. But to my knowledge, Unreal, and actually I met someone from Unreal at the Thornton Thomas Study event last week, kind of chatted with them about this, and they don't have any analysis built in. And it's very unlikely where they're going to go because their bread and butter is still video games. This is extra. It's cool. But I was talking to him, he's like a team of like two, like one West Coast and one East Coast. So not, unfortunately, at least Unreal is unlikely to kind of build it automatically for us.
Have you looked into platforms that would allow you to present this as a web app instead of an executable?
That's a big thing that actually Eric, who I mentioned, has been looking at, because that has been a kind of a, not a hindrance, but a hiccup that we have to figure out of like, how do we then get this into the hand of a client, get sent a file, their IT has to unblock said file. So there are some annoyances there. But that is something we're looking at. I think Unity is the platform that's more web-based focused. And so that might be one potential solution. But there's various things that we're looking at. There's one, I'm blanking on it. It's like, I'll have to look up what it was called, but it was something, it's like ray streaming. The idea to stream the visual, like the visual renders on some server and just streams it, which is interesting. I think that's one of the things we're looking at. So it's not like it's just on Unreal, it's just like almost a video. But there's the IT challenges of that one I'm not fully abreast of, yeah.
Have you got?
Sure. So go ahead.
Go for it.
All right. So you showed some screenshots that looked like they were in sort of like a first person walk around sort of view.
Yeah.
And then what you're showing now is more like an aerial flyby.
Yeah.
Do you feel like one of those two methods is easier or harder for the client to understand? Or like to get the, you know,
Oh,
the
yeah.
message of the simulation from?
Yeah. I think it depends on the scale of the project. So in this project, we're looking at site development. It's about 400,000 square foot, 5 different program types. So it's always the client, the architect, and the end client. We're always thinking at scale, like well, how does it all look together? And so in this one, well, we have right new space will like fall to the ground and now walk on the ground, hopefully the ground's there. That's good. You know, you could view that as well. But kind of what we were thinking about as a project team was always the whole thing at a time. Whereas I think that other one where we were looking at just the gallery space, it was more of I'm in the gallery space. What's it feel like? So the walk mode we used quite a bit more in that case.
I mean, I've found with my students that some of them really look like they'll do the simulation and then they'll like do a perspective view inside of it to show the simulation plane that they put in.
Oh yeah.
And it feels like it's so perspective foreshortened that I can't tell if they really, you know, can understand what's happening in the space.
Oh, like they're just looking at like a corner or an edge. They're not seeing.
Or like the, you know, the grid in front of them is like so magnified and then the grid in the distance is so tiny that like it feels like it gets rid of the like sense of what, you know, how much of the space has one character versus another.
Right. Yeah, I think that's I think I know what you're talking about, kind of you're blocking the view from other things. I don't have it here as much, but I think in that other example, like the people, etc., in all of these, we have ways to like turn off all the context. And so you can kind of take a step back and just say, okay, almost make it a sheet again and say, what's it actually look like? So we try and provide kind of both. Because you can get lost in the details too, especially a client can be like, oh, I'm sure I've had this discussion of like, why is it so dark in that corner? Is that important? And if like that's the render you do, that becomes the discussion. But I think starting, at least on this one, what we always did was kind of start it far out. And then you can kind of see, well, in this case, because we looked at the courtyard so often, we had these like saved views to say, okay, this is what your courtyards look like. Dark. We don't want that. Like from the other direction, very dark. And so we definitely learned over time. Like we didn't start with these saved views. We learned from like the first thing, like what was important to them, what was important to us, which was, I think, an interesting challenge.
What's going on with the pink house? Is that the guy who didn't want to sell it to the developer?
That's what I was gonna ask. So the pink house is the town jail.
Oh, yeah.
It is historic and it is going to get renovated into something, but for this project, it was just going to be left there and then they would do something else. But we left the pink jail house, so it was there.
Is it like a historical, like not in use or are there?
It's not in use. It's not in use. I don't know. But yeah, I don't think we touched it in any of these. We just left it there. Yeah. At one point, and this was going to be cool. I mean, like all these projects, it's very different now. Now it's condos and apartments. But it was going to be a hotel, and this was going to be like the hotel restaurant, like outdoor dining, all that stuff. It was really cool, but it's kind of cool. Things move around. But yeah, that's why we didn't touch it, because it was destroyed. So we just included it. Yeah.
Have you gotten feedback from clients after they like implemented the recommendations about how it actually turned out? And particularly thinking about that gallery.
Oh, yeah. So we have gotten really good feedback from clients that it really helped them understand like what they were looking at. So like for this particular project, it really helped them understand those sun hours and the ends. Well, it's gone through many renditions, but it is much closer. Oh, sorry, I forgot to do with. I don't have all the data loaded, so that option combination, there's no data for it. So like, but so like the end result is much closer to this than when it started. So it really helped them like morph things and move things. And they were, I think, appreciative that the analysis wasn't just static. It really let them think it through, which was really good. On the gallery side, they also really appreciated kind of some of those visuals, especially on the glare. The glare was really important to them. There's actually an architectural gallery, and what they do in there is the pinup sessions. And what they would architectural pinup, so they would have drawings pin up, and like no one could see the drawings because there was so much glare on the boards. And that was very important. And so that was actually a project we just finished in June. So they haven't done the construction, they haven't installed those pins yet, but looking forward to see how it looks after those are installed. Because again, understanding even with those that yes, some of it's still going to have some glare, and lets them know, okay, well, our pinup boards are here back. That's so it's not perfect, but it's a vast improvement. Yeah. Cool. Well, yeah, I'm happy to, well, definitely, connect and talk game mention really anytime. But yeah, thanks for letting me kind of share out, and yeah, glad we could kind of all get together to, as a BIPSA and look at all this. Okay, I guess if there's no more questions, I'll stop the recording so we get something kind of loaded, and then I mean, I don't think we necessarily need to certainly we could go across the street, but we could stay here and just chat about the chapter, things like that. Yeah.
Thank you very much.
Yeah, thanks. Figure out how to turn off my own system.
A different system in every room in our